So once we've learned some things about the distance formula, one thing that we're able to then do is figure out if any given 3 points in the xy plane are the corners, the vertices of a right triangle. In other words, do they make up a triangle where one of the angles is 90 degrees? So here I've just written down notation. I have 3 points, points 1, 2, and 3. I've called them x1, y1, x2, y2, and x3, y3. Pretty original, I know. And then think about if we have 3 points, there are 3 distances then. You can draw a straight line, which would be the distance from point 1 to point 2, straight line distance from point 2 to point 3, and then straight line distance from point 1 to point 3 or point 3 to point 1, however you want to look at it. So we get 3 lines. They'll close off a triangle, assuming that no 2 of the points are the same. And then we want to look at, basically, do the distances fit the idea of the Pythagorean theorem? So let's say one of these sides is the longest. So I'm just going to choose in this example, we'll say the distance from point 1 to point 3 is the longest. So if that's true, then what we will actually do is we will call that distance our c in the Pythagorean theorem, and then what we need to do is just name the other two a and b. And remember, c is the only one by itself on one side, so it doesn't really matter if we call the first one a and the second one b, or the first one b and the second one a. As long as c is the longest, that's okay. Now if you have more than one side that ties as the longest side, so let's say you have, 2 of the sides are tied for the longest, then that's going to turn out not to be a right triangle. Or if all 3 are tied for the longest, that's not going to be a right triangle. So if you just have one that is the longest, then this is what we'll do. And remember, we'll set up our Pythagorean theorem, which just simply says, obviously, that a square plus b square is equal to c square. So what we'll be doing is finding the lengths of these distances. So we'll use the distance formula to find those lengths, and then they need to fit into this Pythagorean theorem and make sense. Okay, we'll do 2 examples in this video. So our first example, we have 3 points. So we have 1, 1, -2, -5, and 3, 0. So what we'll first do is we'll figure out the distance between 1, 1 and -2, -5. So that distance there is going to equal the square root of, so we'll do the x's, subtract, so x2 minus x1, so -2 minus 1 squared, plus, now we'll subtract the y's, so that'll be -5 minus 1 squared, all under the square root, just using our distance formula here. Okay, so that will give us the square root of, we have -2 minus 1 would be -3. When we square -3, that's 9. Plus -5 minus 1 would be -6. We square that, we get 36. And so that gives us the square root of 45. I'm going to go ahead and leave that alone for now. We would normally simplify that, but I'm going to go ahead and leave that. Okay, next one I'll do is the distance from -2, -5 to 3, 0. So for that distance, we'll have square root of quantity of the x's subtracted, so that'll be 3 minus -2 squared plus 0 minus -5 squared. Okay, so 3 minus -2 would be like 3 plus 2, which is 5. Square 5, and we get 25. 0 minus -5 would be 0 plus 5, which is 5. We square that, and we also get 25. So that gives us a distance of square root 50, which, again, I would normally reduce that radical, but here I'm just finding these distances, and I'm going to end up plugging them into a formula anyway. So I'm not going to simplify. And then the last one, let's pair up these, the first and the last one. So the distance from 1, 1 to 3, 0. So that will equal the root of quantity 3 minus 1 squared plus quantity 0 minus 1 squared. Alright, easy math here. 3 minus 1 is 2. Take the square of 2 and we get 4. And then 0 minus 1 is -1, square that and we get 1. So 4 plus 1 gives us the square root of 5. So we have our 3 distances And now we say, well, which one's the longest? That one's going to be C. This one's the longest. Root 50 is the biggest number out of root 45, root 50, and root 5. So this is going to be C. And I'll just call the other two A and B. Okay, and so now the question is then, does A squared plus B squared equal C squared? Is that true? If it's true, it's a right triangle. If it's not, then it isn't a right triangle. So let's go ahead and plug in our information. So we get the square root of 45 squared plus B is the square root of 5 squared equals the square root of 50 squared. And so now if we square a square root, that just gives us back the number underneath, because those undo one another there, so we get 45 plus 5 equal to 50. And that's certainly true. So since it's true, we know, yes, this is a right triangle. Alright, so here's one more example just to show you the difference. So we'll go ahead and first find the distance from 2, 2 to 3, negative 1. So if we plug that in our distance formula, that'll give us 3 minus 2 squared plus negative 1 minus 2 quantity square. Take the square root of that. 3 minus 2 would be 1. 1 squared is still 1. Plus negative 1 minus 2 would be negative 3. Square that, we get 9. So 1 plus 9 gives us the square root of 10. And then let's do 3, negative 1 to negative 3, negative 2. So our distance there, we'll get negative 3 minus 3 quantity square plus negative 2 minus negative 1 quantity squared. And that equals, so we have negative 3 minus negative 3 is negative 6. Square that, we get 36. And then we have negative 2 minus negative 1, so like negative 2 plus 1, which would be negative 1. Square that and we get a positive 1. So that gives us square root 37. Alright, and the last distance, which would be point 1 to point 3. So we're finding the distance from 2, 2 to negative 3, negative 2. So I have negative 3 minus 2 squared plus negative 2 minus 2 squared. That's going to give us negative 3 minus 2 would be negative 5. Square that, we get 25. Plus negative 2 minus 2 would be negative 4. Square that and we get 16. 25 plus 16 would give us square root 41. So out of these three distances, we can see that the 41 number is the largest, so this is going to be our C. So we'll make this A, we'll make this B. So if we plug this into the A squared plus B squared equals C squared, then that would mean we should have square root 10 square plus square root 37 square equals square root of 41 squared, right? So square undoes the square root, so that should tell us that 10 plus 37 equals 41. And we can tell that certainly is not true, right? So that's going to give us something that is false. So we get a false statement if we try to use this information and plug it into the Pythagorean theorem. So in this example, we would say this is not a right triangle.